we have to prove that triangle DAB is congruent to triangle BCD. So first, what we have given? We have given that AB is congruent to CD. So let's write this. AB segment is congruent to CD segment. So first we will show that this triangle is congruent to that triangle. Next we will show that this smallest triangle are congruent too. So after this we can show that triangle DAB is congruent to BCD. So first, like I said, we will show that these two light blue triangles are congruent. So let's put that. This is our 1 and 1 triangle. We will show that these two triangles are congruent. We have that AB is congruent to CD. These triangles are right triangles. AB and CD are hypotenuse. What else we have here? We have that DE plus FEF is equal DF. And we can write that BF plus FE is equal BE. So let me write this, that BF plus FE is equal BE. And we have given that DE is congruent to BF because DE is congruent, segment DE is congruent to BF and segment EF is congruent to FE by reflexive property. So we have, let me start from the right side. We have that DF is equal DE plus FEF. DF is equal DE plus EF. And this is equal because DE is congruent to BF, so we can substitute DE by BF because DE is equal BF. So we have now BF and we just copy EF plus EF. This is equal BF, we will copy, and EF is congruent to FE by reflexive property. So we can substitute EF by FE. So we have BF plus FE is equal BE. So this is equal BE. So we have that from this equation that DF is equal to BE. We show that DF is equal BE. So it means that DF segment is congruent to BE segment. So if we have that this segment is congruent now to that segment, and we see that this is right triangle. This is right triangle. Hypotenuse AB is congruent to CD. This is given. So let me copy this one more time. AB is congruent to CD segment. This is given. So because we have here right triangles and hypotenuse and one leg are congruent in one triangle to hypotenuse and one leg in the other triangle, we can use hypotenuse leg congruence theorem. So by hypotenuse leg congruence theorem, we have that triangle ABE is congruent to triangle CDF. So we can write that corresponding parts of congruent triangles are congruent. So we have that AE segment is congruent to CF. Is congruent to CF. So now if this segment is congruent to that segment, and we have also here right angle, because we have here straight angle and this angle is 90 degrees, so on the other side we have to have 90 degrees here. The same will be here. We have here right angle and we know that DE is congruent to BF, and these sides are, so we have side angle side, side angle side, congruence postulate. So we can write now that because AE and CF are congruent, let me write one more time, and DE is congruent to BF, also the angle DEA is congruent to angle BFC. So we can write that by side angle side congruence postulate triangle DEA is congruent to triangle BFC. So we show that this triangle is congruent to that triangle, and these two triangles are congruent too. So now, because these two triangles are congruent, it means that DA and BC are congruent too. So we have that DA A is congruent to B, C. Why? Because triangle DEA is congruent to BFC. It means that corresponding parts of congruent triangles are congruent. So this segment is congruent to that segment. DA is congruent to BC. And we have given that AB is congruent to CD. Let me write this. AB is congruent to CD. This was given. And what else we have? BD is congruent to DB. BD is congruent to DB by reflexive property. So we have side, side, side. So by side, 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 congruence postulate, we have that triangle DAB is congruent to triangle BCD. This is my solution.